Hello everyone, my name is Satyajit Pattnaik and you are watching my channel. I have lots of news and surprises for you. One of the announcements I want to make is I am going to come up with tons and tons of projects related to NLP, deep learning, computer vision and large language models on my channel, and that is going to start exactly from April. Every week a new project will be launched. And in case you have a specific requirement that you want me to come up with a video on a particular project, let it be any NLP use case or LLM or anything, just let me know your problem statement or whatever you want me to build a project on. Let me know in the comment section and I will definitely come up with a video as soon as possible. Now, coming up with a video on a customized request is very difficult. It might take some time, but I will definitely come up with a video. Now, apart from that announcement, I just also wanted to announce that I'm going to launch some NLP series as well on my channel, where some of the NLP contents will be made live for you to understand and for you to get into more into the NLP concepts. Because once you understand NLP, your route or your career path or your understanding towards LLM will also be helpful, because LLMs are all built on NLP concepts, right? So those videos will also come up on my channel very soon. Just please wait for it. Apart from that, I have made a simple short video on a concept called as cosine similarity. It is a very important concept, especially in the field of statistics, mathematics, and even in NLP. While we try to understand and interpret different NLP sentences, how cosine similarity works. I hope you will enjoy this video. In case you are enjoying this, please also let me know in the comment section. And in case you have any kind of feedbacks, whether you don't like my way of teaching or whether anything, the dark background is not good or anything, in case you have any feedback on the next video that I'm going to show you, please let me know, because that will help me to prepare a better version of it. That's all about it. See you in the video. Learn cosine similarity, and in case you have any other request, any other requirement, comment section. See you in the video. Hi, let's talk about cosine similarity in this video. What do you mean by cosine similarity? Now, as per Wikipedia, this is the definition by Wikipedia. As per Wikipedia, cosine similarity is a measure of similarity between two non-zero vectors defined in an inner product space. Cosine similarity is the cosine of the angle between the vectors. That is, it is the dot product of the vectors divided by the product of their lengths. It follows that the cosine similarity does not depend on the magnitudes of the vectors, but only on their angle. So theoretically, if you might not have understood, we will try to take some examples in order to accomplish this task of understanding cosine similarity. By the end of this video, I can guarantee you that your understanding on cosine similarity will be clarified. Okay, so simple terms, let's say cosine similarity is used in one of the cases. Let's say you have a word or you have a sentence. This is a boy, and you have another sentence, boy is good. Just arbitrarily taking some examples. Now in this case, one of the use cases will be how similar are these both sentences. Now to find the similarity between both sentences, you take the help of cosine similarity concept. Okay, now in this case, how many words do we have? Let's not remove the stop words, including the stop words. It's going to be 1 2 3 4, repeat, 5. So ultimately there are 5 words, right? Now if I have to draw this on a graph, I would need a 5-dimensional graph, which is impossible to draw, right? So for the sake of understanding the concept of cosine similarity, I will be taking some easy examples. Okay, so let's say my first example is going to be, we will be taking 2 sentences. One of them is going to be hello world, and another sentence is going to be hello. How many total keywords do we have here? 1, 2, and repeat, right? So even if I have to draw this, I would be needing a two-dimensional space, which is possible. I can draw it on the screen, right? So first what I'm going to do is I'm going to draw a matrix. I'm going to draw a table. Okay. Now here let's say I will write it down as hello. Here I will write it down as world. Now very simply I'm using a bag of words concept or a one hot representation. If I find hello in my first sentence, so this is my first sentence, this is my second sentence. Hello is present? Yes. 1. World is present? Yes. 1. Hello is present in sentence 2? Yes. 1. World is present? No. So this is how my matrix will be. Now let's try to draw this graph. On my x-axis, I will have hello. This is my first keyword. On my y-axis, I will have world. Okay. So if I have to draw the coordinates, let's say 1, 2, 1, 2. Now what is my sentence 1? Sentence 1 is nothing but 1 comma 1. Where it is somewhere here. What is my sentence 2? This is 1 comma 0, which is here. Now how will my points look like? How will my lines look like? Starting from the origin, this will be my first line, this will be my second line, right? So in a box, in a square box, this is like a square box, right? If you have a line like this, what will be this angle? I hope these are basics of mathematics, I don't have to explain. The overall is going to be 90 degrees and this one is going to be 45 degrees, right? So this particular angle is nothing but 45 degrees. Okay, so what will be cos 45? Now again, basics of mathematics, if you don't remember, please go back to basics, try to understand what is sine, cos and tan, at least these three, sine, cos and tan. But let me remind you, cos 45 is nothing but 1 by root over of 2, which is nothing but 0.707. To be precise, if you round it up, it will be 0.71. Okay, so 45 degrees angle between my two lines. So in short, my cosine similarity between hello world and hello is nothing but cos theta. In this case it is cos 45 degrees, which is 0.71. Understood? We will take further examples. Okay, now let's say my second example is, my first sentence is hello world, my second sentence is hello, 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 hello. Okay, 4 hellos. Now I will draw the same matrix here. The first word is going to be hello, second word is going to be word. This is sentence 1, this is sentence 2. Now is hello present? Yes. Is world present? Yes. Is hello present? Yes, but 4 times. So 4. Is world present? No. Now I will again draw the graph between hello and world. So let's say 1, 2, 3, 4. 1, 2, 3, 4. What will be the first coordinates? 1, 1, which will be here. Second coordinates is 4, 0, which is here. Okay. Now if you draw the line from here till here, what is the angle? The angle is still 45 degrees. So what do you mean? The meaning here is cosine similarity between hello world and hello, 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 hello is nothing but cos 45 degrees, which is 0.71 again. What does that mean? That means it follows that the cosine similarity does not depend on the magnitudes of the vectors, but only on their angle. So angle matters, magnitude does not matter, right? Here the magnitude on x-axis are 4 units. Here the magnitude is 1 unit. Does not matter. The cosine similarity between hello world and hello and hello world and hello is basically same, which is 0.71. Okay, so that is cosine similarity. Now we will also take another example to have our understanding even better. Okay, so cosine similarity is determined entirely by angle and not length, right? Now I will try to do something like, let's say my two sentences are hello world and hello world, right? Same matrix. Now in this case, hello and world, sentence 1, sentence 2, hello is present, world is present, hello is present, world is present. Now if I draw the graph, both the points will be here. Both the points are here, right? So basically from point 1, which is 1 1, you are basically drawing a line on top of it, right? What will be the angle? The angle is 0 degrees. So what will be cos theta here, which will be cos 0 degrees, which is, if you know what is cos 0 degrees, cos 0 degrees is 1. What does that mean? That means the cosine similarity between exactly two similar sentences is 1. Lastly, I will take another example, which is, let's say I have let's say hello. Okay, we are talking about two dimensions, so I will just take hello as my first line and world as my second one. Now I will draw hello and world. Hello is present, yes. World is present, no. Hello is present, no. World is present, yes. So the first coordinate is 1 0, the second coordinate is 0 1. Now if you draw this graph, hello and world, 1 0 is here, 0 1 is here, right? Now what is the angle between two lines, here and here, which is going to be 90 degrees, and cos 90 degrees is 0. So the cosine similarity between two completely exclusive statements where none of the words are similar is basically 0. Okay, so S1 is not related to S2, or sentence 1 is not related to sentence 2, because the cos theta is nothing but cos 90 degrees, which is nothing but 0. So to summarize, when two sentences have nothing in common, the cosine similarity is 0. So normally what do we say? Cosine similarity always lies between the range of 0 to 1. The more similar patterns will be around 1, less ones will be around 0. So all these things are about cosine similarity. Now, what is the mathematics behind it? Let's try to talk about the mathematics as well. So mathematically, cosine similarity formula is here. Cosine similarity is summation of I is equals to 1 to n, going to be a of I, b of I divided by summation of y I equals to 1 to n, a of I square root over multiplied with b of I square summation root over. Looks complicated, but trust me, it's going to be very simple to understand. Okay, now what do you mean by I? Why I is your index? Okay, now I'm taking the first example once again, which is hello world and hello, right? If you remember the first example, hello world and hello, right? In this case, what was our cosine similarity? It was 0.71. Let's try to take the same example and try to use this formula to obtain our final cosine similarity results. Okay, now I will be drawing the graph again. Hello world, 1 1 1 0. All good. Now what? So here, how many words do we have? We have two words, right? So from 1 equals to I equals to 1 to n. So what will be the formula here? The formula here is summation of I is equals to 1 to 2 a of I b of I divided by a of I square, same summation, multiplied with b of I square, same summation. Okay, I equals to 1 to 2. Cool. Now what? So in my first case, what is AI into BI? 1 into 1, 1 into 1. In the second case, it is 1 into 0, 1 into 0, right? In the denominator, AI square, how much is AI square? 1 square plus 1 square root over, multiplied with what is BI square? BI square is 1 square plus 0 square root over, right? This is your A, this is your B. Try to remember this thing. So what will be the output? 1 into 1 is 1 and 1 into 0 is 0. So in numerator I will have 1. In denominator it will be 2 root multiplied with 1 root. So it is going to be 1 by 2 root, which is 0.707. Same like the first. Okay. So understood? Now we will try to take a little bit complex example and try to use the same formula. Okay. So let's take an example. Let's say my first sentence is I love data science, and my second sentence is I love SEP. Okay. So I'm going to draw my matrix here. Obviously I'll have to extend it further because how many words are there? 1, 2, 3, 4, 5, right? So 1, 2, 3, 4, 5. I love data science and ZEP. So for sentence 1, sentence 2, or basically A and B, right? So for A and B, I yes, love yes, data yes, science yes, ZEP 0. I love ZEP. Okay, understood? Very simple. Can we plot this graph? Because this is a 5-dimensional data, we cannot plot the graph, right? Oops, we cannot plot. But we will be taking the example. I will try to copy the formula once again. Summation of I equals to 1 to n ai bi divided by summation of I equals to 1 to n ai square root over multiplied with bi square and 2. Okay. Now in the first case, what is ai multiplied with bi? 1 multiplied with 1 plus 1 multiplied with 1 plus 1 multiplied with 0 plus 1 multiplied with 0 plus 0 multiplied with 1, right? Numerator is sorted. Ai square, 1 square plus 1 square plus 1 square plus 1 square plus 0 square, right? 1 square plus 1 square plus 1 square plus 1 square plus 0 square root over multiplied with 1 square plus 1 square plus 0 square plus 0 square plus 1 square. 1 square plus 1 square plus 0 square plus 0 square plus 1 square. How much is this? Cut, cut, cut. 1 plus 1, 2 divided by 4 root over 4 root over multiplied with 3 root over, right? How much is this? 2. 4 root over is 2, right? So this becomes cancelled out. 1 by root 3. How much is this? If you take the help of calculator, 1 by root 3 will be somewhere around 0.5, right? So the cosine similarity between both these lines, I love data science and I love ZEP, is going to be 0.57777. Or if you want to round it up, it is going to be 0.58. So that's all about cosine similarity. I hope you understood. It's a very simple concept based on cos theta, based on your different angles between two different vectors. You will be able to find the similarity between texts. So this is one of the texts. This is one of the concepts that we use vastly in NLP in various use cases. One of the classic use cases is string pattern matching. If you are dealing with two different paragraphs or two different texts, you want to find the commonality between them, or you want to find how these strings are matching with each other, you can probably take help of cosine similarity. Another real time use case will be let's say you are doing a resume filtering based on job description. So you have job description, you are using NLP concepts, you are extracting all the tokens. You have resumes, you are parsing the resumes and getting all the tokens, and then you are probably finding the common skills or common elements. So in this case also you can use cosine. So multiple use cases are there around cosine similarity. At the end of NLP, we'll probably go through one of the use cases where we will be using cosine similarity. That's all about it. See you in the next video.